We're going to continue in our videos for creating the string utilities. This particular video is going to do the step 5 of the 6-step programming process. Let's go back to our editor here. We have our copy string here, and we're going to go ahead and fill this out. The step 5 is a design part. So we're going to put design in here, and we'll take here, we're going to put initialize function and variables, and then we're going to go ahead and fill this out as to what the design is going to be. For the design of this circumstance, we're going to loop until we see the null character in the source string. The loop is also limited to the max strlen, so we protect it as promised here. We're going to assign the source character to the destination element, increment the index, and assign the null character to the next destination element. We'll leave our temporary result in here so that we'll still continue to be able to compile and run correctly without any failure. So we'll save this and we'll move on to concatenate string. We'll go ahead and write the design for that. And our design is complete for this particular function. We'll initialize the function and variables, and we will have a step 2 part of this where we specifically set the destination index to the length of the destination string. We're going to start at the end of that destination string to load the items from the source string. We'll loop to the end of the source index and limit it to max strlen. We'll assign the source character to the destination index. So we're taking that initial source character and dropping it in the destination. Increment the 2 indices here. We'll assign the null character to the next destination element. This is just a safety thing, so no matter when this loop ends, there'll always be a null character at the end of the string. That just keeps that from ever being a problem. So we're ready to move on from here. Compare string is a little bit more complicated, but not terribly. Let's go ahead and take a look at the design for that one. And our function compare string will start by initializing function and variables, as I always do. We will loop to the end of one of the 2 strings. We'll try to loop to the end of both of them, but if one fails first, either one fails first, it'll stop the loop. And if it does stop the loop, then we will fall through to here. But what will also happen is we're going to find the difference between each currently aligned character. In other words, index 0 of one str and index 0 of other str. We'll compare them. And then index 1 and 1, index 2 and 2. But we'll check for a non-zero difference. If it's not 0, then we will return that difference, and in fact that will be the difference, the positive, negative, or 0 quantity. It'll be positive or negative quantity that will happen if we found a non-zero difference. Otherwise, we increment the index and we come back up to the loop and we continue until we run out of one of the 2 strings. If we do run out of one of the 2 strings and we never found a difference, that means that they're equal up to that point. So if we assume that, we fall through here, assume the strings are equal up to that point, return the string length difference, and we'll use our getStringLength function for that. So again, we've got this designed here, and this is our step 5 here because we're still designing our functions. Let's go to the next one, getSubstring. Again, a little bit more complicated. Let's go ahead and design that one. And we have our initialize function variables. There's several things to initialize here. We're going to set the length of the source string. We're going to initialize the destination index to 0 because that's going to be, we're going to put it into the destination string. We're going to initialize the source index to the start index parameter we're given here. We're going to create the pointer to a temp string because we're going to use a temporary string here in place of our source string so we don't have issues with aliasing, as we mentioned before. Now what we'll do inside here, if our indices are within the limits, in other words, these 2 indices are legitimate and within the limits of the source string and so on, then we'll go in here, we'll create the temporary string, and we'll copy the source string to it. Then we will loop across that requested substring, and that means we're going to go from start index to index inclusive. We'll assign the source character to the destination element. That's easy enough. increment both indices, the source and the destination, and then we'll add the null character to the next destination string element to keep up with the spelling as much as we can. Once we've done that, we don't need that temporary source string anymore, so we will free that memory. We have to free all the memory we use whenever we're using temporary strings or whenever we've malloced any data. Now, if we did not end up with indices within the limits, we'll fall through here and we'll go ahead, we'll assume indices not in limits, and we'll create an empty string with that null character. And then we've got our temporary results. So we're ready to go ahead and put this one out. This is step 5 of get substring, and we can go on to our find substring and see what that's going to look like. And we find that the initialize function variable starts again. We're going to initialize the test string length. We'll need to know the length of what we've brought in here. We're going to initialize any other variables we need. We're going to have an outer loop that simply loops across that test string. And then we're going to set an inner loop index to the current test string. In other words, we're going to start at the beginning, wherever we landed on the test string. We're going to start there, and then we're going to set the internal search index to 0. We'll loop to the end of the test string. So just go looking for that combination of letters. And while the test string substring characters are the same, if they are. If they're not, this falls through and we go into the next character in the test string. If we do start finding characters that are the same, we increment the 2 indices. We check for the end of the substring. In other words, we've search completed here. And at that point, we'll return the current test string index that we got up across here, saying that's where it starts. That'll be the end of the inner loop here. The outer loop will have to increment the current test string index to go on if this loop did not succeed in finding the test string. So we end that loop. And by the way, I note this end loop thing. You see a loop here and an end loop and a loop here. I write these together. I draw this, and then I do this, and then I start filling in the blanks. This keeps me under control so that I don't go outside of where I meant for the code to be for a given loop. If we fall through the whole loop and we've never found it, we haven't returned it, then we'll assume our tests have failed and we'll return our substring not found. So we're good with that. We can move along to set stir to lowercase, and let's take a look at the design for that one. And we will initialize our function variables. We'll create a temporary source string. This is because, and we actually did this in our main program here, where we're taking something from the destination string here and putting it into test string into destination string here. We did a comparable thing up here where we put destination string into destination string. We're keeping the aliasing issue from happening. So we're going to create a temporary source string. We're going to initialize the source string index to 0. We're going to copy the real source string into the temporary string. We're going to loop up to the end of that string, limited with Max Stirlin. And we're going to change the letter to lowercase as needed and assign to destination string. But to change that to lowercase, it would be much more modular and intelligent to create a new function called setchar to lowercase. So we're going to come down here and we're going to create a new temporary function here with the header and with a stub quantity and stick that in. So we'll do that now. This is our setchar to lowercase function. It tests a character parameter to see if it is uppercase, and only under that circumstance changes it to lowercase. Precondition is that we're given a character value. Postcondition is if it is an uppercase, we'll set it to lowercase. Otherwise, we don't mess with it, but we do return it unchanged. Here's our function, stub. We have a non-void function, so we have to return something that actually looks like a character. Since we commonly return zeros, we'll make a character 0. Remind ourselves of that. We will go ahead and copy this guy, take him up here, paste him, semicolon, and save. Now we've done essentially the step 3 part. We're doing step 5, but remember that means steps 1, 2, and 3 inside each function. So we've completed step 3 for this part right here by creating the header and the stub. We'll continue on here. We'll increment the index inside this loop. I added in, we need to add a null character so that we keep the string complete with every iteration. Here's the end of my loop. Remember, that reminds me that I'm working within it at this point. And remember also that we have a temporary source string that we created, so we need to free the memory on that. And again, we'll leave our temporary result in here so that if anybody calls this function, it doesn't do any harm. Now with that, we're done with step 5 of this function, and now we can go to the next one, which happens to be the one we just designed. So we'll go ahead and set this one up with our step 5 design. Here is our design. Commonly we initialize the function and variables. It turns out that's not necessary here, but I still always put this in here to remind myself. I'm going to check for the character between A and Z, capital A and Z, inclusive. If it is a capital A to Z, I'll convert it from that uppercase letter to a lowercase. And then whether this is done or not, I'm always going to return the character. So every character that comes in here, a character will go out. If it happened to be an uppercase character, it gets changed. Otherwise, it doesn't. Now this would be the end of our list of functions. It's the end of what we designed here. However, there are 2 more functions that I want to talk about. We cannot test at this point because they require opening files and so on. So I want to talk to you about another function called getLine2. And we're simply going to design that function here so that we can continue on with it and it will become one of your string utilities. I will go ahead and do that now. So what I'm going to do here is I'm going to open this guy up here. This is a getLine2, and we're going to just do it and then come back later and you'll see how it's used. So for right now, we know that in an open file it finds a given text, skips leading white space if it's specified, stops searching when it gets to a given character or a given length. The precondition is that the file is open with a valid file pointer. The character buffer has enough memory to hold the data. The stop character and the length are valid quantities. The output or the post condition is that it ignores leading white space as specified, captures all printable characters and stores those in a string buffer. And exceptions are it's going to return an incomplete file error if no valid data is found, or it's going to return no error if it has a successful operation. Now in this program right here, I've got a couple things going. I'll go ahead and put this up into my header and get that done so that it would be recognized, but that doesn't matter, it's not being used. But there are 2 problems here. One is I've got a file star pointer, and the other I use a data type called Boolean. And those 2 are unknown to the system at this point. So let's see what happens. So we'll do a clean, and then we'll just do the make. Now we have unexpected declaration specifiers before a thing called Boolean. And so, because it doesn't know what Boolean is, we need to tell it what that is. And it turns out in C language, officially, and now this has been changed more recently, but for right now, and for the C language we're using, there is no Boolean data type. But we're going to create one. And we're going to do it by putting this under our global constants. We're going to create a type def. In other words, we're going to define a type. It's going to be enumerated. It's going to have the values false and true. And we're going to call it a Boolean. All right, now it turns out that will be global across all files, so we can use this anywhere we want. Specifically, we're going to use it here in string utils C. So now let's see if we fix that problem. And we don't have a problem with Boolean anymore, but we have on string utils 19, we have A before A token, kind of a goofy one. Let's see what that means. That is line 19. So we have line 19, and we have Boolean here, and we've also got file star pointer. So it's expecting something, a parentheses before the star. These character A's are kind of goofy things that are a product of this interface here. but we have something before a star and it doesn't know what that's supposed to be. Coming back here, that something is a thing called file. Now file is unknown to the system right now. We're going to need to put in some header files for this operation here. The header file for this particular item is going to be stdio.h, and that's going to give us our file operations. It will now start recognizing the file before this pointer here. It's not actually in the language, it's in a library. Let's see what this does for us. We now have a happy compiler. And let's just review what we had to do to make that happen. This is saying it's going to use a Boolean. So we had to define that, and we actually defined a data type called Boolean and gave it data, or data quantities. We also had to define what the heck file was. It didn't know what that was. So we said, fine, we'll tell you that it comes inside of stdio.h. And now again we have a happy compiler, and in fact we should be able to run this guy, and we're still doing all the good things here. It still compiles, it still runs. We haven't broken anything, although mostly what we've been doing is design work. Let's take a quick one more pass through here. Get line 2 itself needs to have a step 5 done for it, so let's go ahead and do that now. And now we have step 5 for the get line 2. We'll initialize our functions and variables. We have to initialize the character index. We're going to load our buffer here. Our status return starts with the idea that there won't be any errors. We have a buffer size available flag we'll set to true, and then we'll initialize any other variables we need. The first thing we'll do is prime the first loop. We'll get the first character, and we're going to run a loop to consume the leading white space if we've been given that flag from the omit leading white space. If that's the case, we're just going to run this loop and keep getting new characters until we've consumed all the leading white space. And that's the end of that loop. Now we get into the meat of the game here. We're going to capture the string. We're going to do that by looping while the character is not the stop character and while buffer size is available, and we're going to use a Boolean for that. We're going to check for input failure using isEndOfFile, and that's a function that doesn't exist right now, so we're going to go ahead and design that one and set that up as part of our step 3 in this process of step 5. So I'll do that now. The isEndOfFile function is very simply going to report the end of the file. It'll return a true if it found end of file. It'll return a false if it is not at the end of the file. And probably better spell it correctly here. We will make a copy of that, and we will place it down here with a semicolon. Come back here, and we're good to save that. And we can come back into our operation here. We've checked for isEndOfFile. If that is the case, we'll return an incomplete file error. Otherwise, we'll continue on. We'll check for a usable printable character. We'll assign that character to the buffer string and increment the index. We'll go ahead and set the next buffer element to the null character. Remember, that's a safety thing to make sure that we've always got a null character at the end of our string. We're going to check for not at the end of the buffer size, and that's simply going to be counting up how big the buffer that was given to us is. Up here, the buffer size. And if that's the case, if we are not at the end of it, we'll get a new character. Otherwise, we will assume that we are at the end of the buffer size. We will set the buffer size Boolean default. That'll end this loop right here. And then we will also set the status return to buffer overrun error. That's the end of that loop, and then we'll return the status data that has been collected as we went along the way. So that's the design for get line 2 in step 5 here. The last one to do here will be our isEndOfFile. We'll go ahead and design that now. And our isEndOfFile is actually pretty short. We're going to use a function called FEOF, but it's a kind of a weird return from it. So rather than just using it straight like it is, we're going to use it in here in isEndOfFile, and it'll be much clearer in our code reading. So we will go ahead and save that. We have already stored this up at the top here. We're in good shape there. We should be able to come back here, run one more compile, and one more run. Everything's still happy, everything's running. This is important because if you let warnings and errors pile up on you, you'll be buried in trying to fix those rather than actually trying to write the program. So this will bring us back to the end here. We've done step 5, which as we recall is steps 1, 2, and 3 inside functions. We've made the design of all of these functions here. We now have step-by-step instructions as to how to run these functions, and our next step obviously will be step 6, which will be to create the code for these functions. So we will end this up at this point.